Hey, ladies and gentlemen. So, what we're going to be doing today is we're going to be talking about electron configuration. And so, electron configuration is about one of our three subatomic particles. Can you guess which one it is? So, hopefully, you did figure out that it's all about the electrons in this case. Okay. And our electrons, if we remember from way back in last week, our electrons should be the same amount as our protons in most cases. Okay. And so our electrons are super important to us because those electrons are going to give us a lot of information about how elements can combine into different compounds, or different combinations of multiple elements together. They also spin in different directions. And so those different directions need to be talked about, and they're placed in different places. And those placements need to be talked about as well. Okay. And so if we're talking about these, the first thing we need to know is how many electrons can fit in our first orbital. So hopefully you remember on your periodic table that you might want to take out for this, okay? On your periodic table, hopefully you remember that our first row kind of talks about our first placement of our orbitals, sorry. And so our electrons, how many elements do we have in our first row? We have two elements in our first row. So that means two electrons fit in our first orbital. And again, we talked about last week how not only does two fit in our first orbital, but the next two orbitals do in fact fit 8 electrons, okay? And that gets into a little bit of a trickiness when we talk about things past element number 18, argon. But for the most part, we do need to remember that it fits 8. Now, we're actually going to talk about the placement of these electrons. And if you look over here, it's got some weird letters and numbers and arrows that we're going to actually be going through. And this chart does make it a little bit simpler once you guys know what you're talking about. Okay, so our energy levels are really the orbitals that we've been talking about, and our orbitals are even smaller placements of our electrons. The energy levels are going to be the rows, so row 1, 2, all the way to 7 that we've been talking about, but our orbitals are going to be the placements of specific electrons. So when you hear me say orbitals, I'm really talking about smaller sections than when we're talking about energy levels, which is the whole overall section. And so we need to talk, there are 4 specific sections of our periodic table. Okay. Our first section is going to be our S block, which is going to be this block right here. Right. Our first 2 columns is going to be called our S block. Right. And what you need to know is this one right here, helium, actually goes along with our S block. Okay, so technically it belongs next to hydrogen when we're talking about energy levels and we're talking about this electron configuration. All right, it has the same kind of information as the rest of our noble gases, which is why we keep it in column 18. But in terms of our electron configuration, it does belong with hydrogen. Our next section is going to be called our P block, which is going to be this section right here. And if you just want to border all of yours out, that's probably the best, or just write the letters above it. It doesn't even have to be bordered. But this P block right here is going to be our next section. And that's anything in columns 13 through 18. Remember, those are going to be where how we count between our S block and our P block is how we count our valence electrons. So S plus P block is how we get to our valence electrons. Okay, so again, if we're looking at just our S and P block, those will give us our valence electrons if we're looking at the largest amount. So if we're looking at our third row and we wanted to get all the way to sulfur, we'd count 1, 2, 3, 4, 5, 6. Sulfur has 6 valence electrons. So that's how we count our valence electrons in any element we're looking at. except for our transition metals, that middle section, and that's where it gets tricky and they have options, and that's going to be a little bit more clear later. But our transition metals are going to be called our D block. And this is our D block right here. And those ones, if you guys look off to the side, actually start one number above the rest of them. So we're going to talk about in a second that our D block actually starts at 3 instead of at 4, like the rest of it. And then our F block is even more complicated, which is our lanthanides and actinides way at the bottom. This is our F block. And those ones, remember, really belong in this section right here. And that's why they get a little bit more complicated even farther as we go down our list. So if we're looking, this right here is going to be called our 1s, is our first row in the S block. Our second row in the S block is our 2s. And then we have 3s, 4s, 5s, 6s, and 7s. So super simple, because if you count the rows on your periodic table, those are the row numbers, just like you're looking at 1s, 1 through 7. Then we just put an S in front of it, or after it. Sorry, not in front. Very similar with our P block. Okay, remember that first row counts. So we skip down. Here is going to be 2P, comes after 2s. 3P comes after 3s. We have 4P, 5P, 6P, and 7P. So those ones, just like the S block, are right there. Okay. Our D block is where it starts to get tricky. Okay. We go from 4s, then we go to 3D. We go from 5s to 4D. We go from 6s to 5D. And we go from 7s to 6D. All right. Now, to make our lives even more complicated, when you go to 6s and you go to 5D, okay, before you can get to 5D, you're going to go from 6s to 4f to 5D, and then you'll go from 7s to 5f to 6D. So remember how I was telling you guys that our first orbital gets 2 valence electrons, or 2 electrons is the max. Our second orbital, or second ring, has a maximum of 8. Our third has a maximum of 8 when we're in our third row. But remember, we can get all the way up to 18 if we count these guys in the 3D block. And that's why we can get to 18. When we're talking about our fourth orbital or fourth ring, we again have 8 when we're in our fourth row. We have 18 when we're in our fifth row. And when we're in our sixth row, we can actually have up to 32 electrons in the fourth orbit or the fourth ring if we're in our sixth row, just because of where our 4F stands and where our 5F stands, the same thing. So that's why things get a little more complicated, and that's why our electrons need to be looked at even more individually. Okay, so if we're looking again at our first row, what energy level will we be in? We're going to be in our 1s. Okay, that's it. Our first row gets our 1s, and that's it. Our second row is a little bit more complicated when we get to 2s and 2p. Okay, so we get to our 2s and 2p right here. Okay, still not too much, but we do have to go through the S and the P block now because we're going through our first, second, 13th through 18th columns. So if you look at hydrogen, hydrogen is, again, our first element on the periodic table. So it only has 1 proton. So it has, we'll put 1 proton. And if it has 1 proton and it's a neutral hydrogen, which means it should be a charge of 0, That means if it has one proton, it needs one electron to balance it out. So we get one electron. And because hydrogen is in our first row, it goes into the 1s block. So it goes into our 1s right here, and we put one electron in there. Right? If we look at lithium, lithium is our third element on the periodic table, which means we're going to have a total of 3 protons, which means we have 3 electrons. And so we're putting our electrons in here. The first 2 electrons actually go in our 1s block because we have to go from the beginning all the way to lithium. We can't just go straight down. We have to go through every element until we get there. Kind of like a board game where you have to go from A to Z, or from start to the end. You got to do the same thing with our elements on the periodic table. So 1, 2 from our 1s block. So our 1s, we get 2 electrons from there. And once we get through our first 2, then we come back down here where we end in our 2s block. Then we get to 2s. And that one, we're just putting 1 electron in there to add to our total of 3. Let's do one more. So we look at carbon. Carbon's going to be over here in column 14. So it's going to have a total of 6 protons. If it has 6 protons, it'll have 6 electrons. And so we do our electron configuration for that. The first 2, again, just like before, we start in our 1s. We start with our first 2 elements. We're going to make our way down to our 2s block and go through our next 2. Then we're going to go across to our 2p block where we're going to end at carbon. So we'll have 2 electrons in the 1s block, 2 electrons in the 2s block, and 2 electrons in the 2p block. So 1s will have 2, 2s will have 2, and 2p we're going to have 2. So if we put all this together, okay, our electron configuration is going to be pretty simple now that we've kind of placed it out for these 3. So if we take a look at this one, our 1s, we're going to have 1 electron. For hydrogen, so if we go down here and we write out our electron configuration, we're just going to rewrite 1s, and then we're going to put a superscript, so a number that goes up top, 1s1. And that's going to be our electron configuration for hydrogen. This one being the energy level. This one being our number of electrons. And that one being the orbital. All right. So our next one, lithium. Lithium, we have a couple different things. So we got to put all of this in our line. So for lithium, we're going to just put 1s2, 2s1. So if we add up our total amount of electrons, the 2 and the 1, we add it up to 3 total electrons, which is what we want. And we know that lithium should have 1 valence electron, which is why there's only 1 in our second energy level, our second row. So carbon had 3 different placements. So we got to do 1s2, 2s2, 2p2. And so now if we add up all of our electrons, 2, 4, 6, that gives us the total amount of electrons. And if we counted just the electrons that are in our second energy level, it gives us 4, which gives us a number of valence electrons. All right. And so now that we've kind of seen what we're supposed to be doing, let's kind of go through one more together just to kind of make sure we're on the same page with everything. So calcium. Calcium is number 20 on the periodic table. So we got to look at calcium. And so if we find calcium on our periodic table, it's right here. So again, we need to make sure we go through all of our elements until we get to calcium. So if we count, we start with 1s, we go 1s2, we go to 2s, and we have 2s2, then we go to 2p, and we have to go through 6, so it's 1s2, 2s2, 2p6, then we keep going to 3s, and we go through both of those. We go through 3p, and we go through all 6 of those, and then we come back down to 4s1 and 4s2, and that's where we end our calcium. So we go down, and let's go ahead and write it out together. We have 1s2, 2s2, 2p6, 3s2, 3p6, and then we end at 4s2. All right. If you have any questions, please reach out. Let me know. Ask Miss Dabney, or I should be back later this week that we can go over any questions you might have. Or check the answer key that'll be on Canvas. All right. Have a good rest of your day, guys.